Greetings, class. I am going to go over section 1.3 functions. 1.3 functions, and going to be talking about the domain and range in a little bit more detail, how to evaluate a function, and then I'm going to show you how to do some things graphically using a program. Because of the nature of this class, it is online, and so you are going to be by your computer. We're going to cover how to do this by hand, but I'm going to show you how to use a computer program as well, and it's called Desmos. If you haven't used it, it's called Desmos Graphing, and it's pretty great. So graphing f of x, that's how you say it, f of x is equal to x squared minus 2. That's how you say this function. F of x is equal to x squared minus 2. So typically, if you're going to do it by hand, you're going to have a table of values, right? And so what do? Well, you just pick these values. You just pick them. Typically, you have some negative value ranges, 0, and some positive value ranges, and you try to have them. Notice you have 2 negative, 2 positive, and then you have here 0 as your median, okay? So you have a little bit before, a little bit after. And so what do? Well, you take this number, you plug it into the function. And so this is f of negative 2, and it's equal to negative 2 squared minus 2. And this becomes negative 2 squared is 4 minus 2, which is 2. And this is how they get this value right here. Okay? And then you do that again for negative 1, 0, 1, and 2, right? Then we plot our points. Okay, now, so again, if you don't know how to plot points, please email me, but here is your negative 2 and 2, right? So you go starting from 0, negative 2, 1, 2, and then, so this is negative 2, and then you go up 2, right? Because this is positive 2, 1, 2. So negative 2 and 2. Negative 1 and 1, that's this guy right here, negative 1 and negative 1, right? So again, you start from here. You go to the left 1 because it's negative, and to the down 1 because it's negative 1. This one is right here. This is also a point. This is 0 and negative 2. So again, because it's 0, you're already right here, but you go down 1, 2. Okay, go down 2. This point right here is 1 and negative 1. So again, starting from 0, you go to the right because it's positive 1 now. Positive 1. And down because it's negative, y is equal to negative 1. And then this one is 2 and 2. Typically, because we had, what was the function? F of x is equal to x squared minus 2. Oops, let's try that again. F of x is equal to, let's go back, f of x is equal to x squared minus 2. It looks like this. It's called a parabola, and we'll talk more about that in the next section. Okay? All right, so determining the domain and range of a function. Remember, the domain is all values of x, and the range is all values of y. So let f be the function defined by f of 1 is equal to 2, f of 2 is equal to 3, f of 3 is equal to 4. So now we're going to write as ordered pairs, right? Giving the domain and the range. So here are the ordered pairs. This is ordered pairs. Right? And so notice this is f of 1 is equal to 2. This is f of 2 is equal to 3. And this is f of 3 is equal to 4. Right? So this is the first function. This is the second function. This is the third function. So again, domain, capital D, brackets, key thing here, and notice 1, 2, and 3. This is our domain, and our range 2, 3, and 4. So again, D equals brackets, and then you list all of your values. All right, so we're going to keep evaluating a function and its range. So now we have a few different things. We have a function f of x is equal to x squared plus 2x. So now you're going to plug in for x equals 3, x equals a, and x equals a plus 2. Notice that this is also a like a function, right? We're going to plug a function into a function. Okay, so keep that in mind. So first things first, plugging in the number 3. That's what you're used to doing, right? And so if this is x squared plus 2x, right? So here the 3 is plugged in here and the 3 is plugged in there, and it gives us 15. Let's take a look at a. Notice we just plug in a everywhere we see an x, so it looks very similar to our original function. Okay, and last but not least, f of a plus 2. So notice we're going to plug in a plus 2 into everywhere there's an x. So this is x squared, right? So it's a plus 2 squared. And then we're going to plug it again in 2 times x, or 2 times a plus 2. And so now here you have to remember you need to FOIL, right? And so this becomes a plus, keeps doing that there, a plus 2 times a plus 2, right? So first, this becomes a squared outer plus 2a plus the inner plus 2a plus the last, which is 2 squared, which is 4. And so notice that is here. These terms combine to become 4a. And then we multiply this out, 2a times 2, sorry, keeps doing that, 2a times 2, and that's 4, which is this guy right here. So notice this is x squared, and this is 2a. All right, so now you have to simplify. You have to find like terms. This is a like term, so 4 plus 4 is 8. This is a like term. 4 plus 2 is 6, and this is all by itself, and so it's just a squared. Now the domain here is all real numbers, and another way to say it, the domain is equal to x. Okay, this is another way to write it. Domain is all real numbers. All right, so we're going to graph this function, and we're going to find the domain, and we're going to evaluate some things. So here is a graph here. So what I'm going to do actually is get out of PowerPoint for a second. Let's keep all of our annotations, and we're going to go to Moodle. We're going to go to the internet, and we're going to go to what's called Desmos graphing. Just type that in, you get there, and click on that. All right, here it is. So there's a few things, but let me just, and so here we're going to write y is, let's find it, equal to, sorry, 4 minus 4, oh, here it is, 4 minus x squared. There we go. Sorry. The Desmos, so this right here, if you can see it, I don't know, bottom part right here is a part of Desmos, and the other part is a part of my computer. And so here we can see the graph. Oops. We can see the graph right here. And notice it's a parabola, and because it's a minus x squared, notice the parabola is facing downwards, it's frowning. And there's a few things that we can look at. This is the y-intercept, right? And so notice I'm hovering over it, and the y-intercept at 0 and positive 4. These are the x-intercepts where the graph crosses the x-axis. is at -2 and 0 and +2 and 0. Okay, and so this is what the graph looks like. This is the graphing program looks like. It's very, very helpful. All right, so let's go back to our PowerPoint presentation, and and we're going to use the formula to evaluate f of -1, and then we're going to go back to our graph and use the graph to evaluate f at -1. All right, and so one more thing, and then we're going to find, the domain is all real numbers. So for any sort of parabola function or x squared, right, it's typically the domain is all real numbers. All right, so let's take the function now and plug in. If you remember, the function is f of x is equal to 4 minus x squared. So notice they just plug in the -1 here. So, again, orders of operations here. The -1 is inside the parentheses. If it wasn't inside the parentheses, you'd get something different, right? We've talked about this. And so 4 minus -1 squared is just 1. So it's just 4 minus 1, and your answer is 3. So now we're going to actually get out of the graph again, and we're going to go look at our function, and we're going to find f of -1. So I think that's this guy right here. Oops. So sorry, it's moving around a little bit. I think if I had but you can see it here. It's actually, it doesn't move around a lot. It's -1 and 3. There you go. So it's -1 and 3. Glitchy. Normally, if I have my computer another way, it stays still. So again, the graphing is just as useful. And actually, if you've taken the time to graph everything, you might as well use your graph. It's not as glitchy. It's just the way I have my computer at this moment. All right, so let's take a look at another function. This is a squared function. So one thing I want you to notice, inside a square, you cannot have a negative value. Okay, you can never have a negative square root function. Sorry, this is a square root function. Okay, because you can't take the square root of a negative value. So again, we're gonna, I'm actually gonna go back to Desmos. We're gonna be doing a lot of back and forth here. I apologize for that. Hopefully you can kind of follow where I'm going. So here we're going to, so the square root of, oh shucks, what is it again? The square root of 1 minus x, okay. Square root of 1 minus x, okay. And so here's a function. It's very similar to what you see on the PowerPoint, okay. And so notice there's no negative y values here. There's nothing below the y axis, okay. And again, we're going to talk about x-intercepts. There's one at 1 and 0, and there's a y-intercept at 0 and 1. So again, this is how you graph the function. All right, and so we can look at the domain and the range. So the domain are all values. So notice you can't have anything this way. So it's all values less than or equal to 1. 1 is included in the domain. And the range is, can you guess? Since there's no values of negative y, so the range has to be equal to y is greater than or equal to 0. Okay? And I would definitely practice writing those values out. See, so same thing. All right, I'm going to not go over this in detail, but I want you to notice that they're giving you a domain, and so you need to take the time to make sure that when you get values outside of your domain, you're not looking at them. So in this particular graph, notice their domain is within, this is 0 and this is 5. And you can't look at anything outside of that domain. That's the important part for example 6, because that's not part of the function. Okay. All right, so evaluating representations of a function. So let's take a look at this problem. People who sustain leg injuries often require crutches. And so here's a formula for it. They have all kinds of formulas for everything. And it computes the appropriate crutch length in inches for a person of height of X inches. So here's the thing when we're reading word problems. Know what your f of x is and know what your x is. So for this particular problem, f of x is going to be the crutch length. And x, and if you have to write these out, I suggest you do it. It's a lot of bookkeeping, is the person's height. Okay, person's height. Oops. Let's go back. A person's height. Okay, and so we're going to evaluate 72 inches, and that's about 6 feet. Okay, so 72 inches. Oops. Let's go back one more time. And then we're going to evaluate 72 again, and we're going to use these particular windows. So this is really, the first one is x is less than or greater than 90, less than 90, greater than 60. And then y is less than 80 and greater than 40. That's what this means right here. And this 10 right here, these are increments of 10. And then we're going to make a table, okay? So the first one, let's evaluate it. So 0.72 times 72 plus 2, okay? So again, this is the height of a person's height. It's easy, and this is the crutch length. As you're doing the math, because there's so many steps involved, to forget what is what. So it's really important in algebra and as you continue on in your math career to know what exactly you're dealing with right here. So right now you need a crutch length of 53.84 inches. All right, so this means that a 6-foot person needs about a 54-inch crutch, okay? So can you explain the results? So real quick, we're going to graph it. So again, the function is f of x is equal to 0.72x plus 2, okay? So let's come out of this again, and I'm going to keep going back and forth and graphing because it is really good practice. So y is equal to 0.72x plus 2. Okay, so here is what this function looks like. Now we want to look at it between a certain window value. Okay, and so let's see if we can do that here. Let's take a look at this. So we are looking at it between 68 so we're going to do 60 to 90 and then 40 to 80. Okay, so 60 to 90 and 40 to 80. So we're going to come into this little guy right here, graph settings, and so we're going to look at it from 60 to 90 in steps of 10. So that's what that little function is here. And so this one's going to be 40 to 80 in, again, steps of 10. Okay, so that's how to do this particular function here. And so let's get out of here. And so this is what we're looking at, okay? Steps of 10. Let's see where this is at right here. So 60 to 80. So 60, this is 60 to 80. So really even a broader range. I'm going to scoot in a little bit. Okay, and so here we have 40. Notice there's 40 is our beginning y, and our 80 is the end of our y. And we can make it so that's all we're looking at. And then we're looking from 60 to 90 right here. So even if I wanted to, I don't think I can include. So, all right, so 60 to 90. So, oops, sorry. What just happened here? 60. Okay. There we go. So 60 is, it keeps moving. Sorry. Maybe I can't. All right. So 60 is here, on the left-hand side to 90, and then again 40 to 80. So this is about and so 72. So notice if you just put in the 72, we're at 53.84, which is what we got. Let's say you're less than that. Maybe you're, 5 feet. So what is that? 60 inches. So at 60 inches, 60 inches, you need crutches that are about 45.2 inches long. Okay, so back to this. Here we go. And so the last part is the table, all right? And so notice they plugged in some values, and you can use your graph for that as well. All right, so determining if a set of ordered pairs is a function. So a function means that something is 1 to 1. For every one domain, there is one range, okay? And you can also plot the points, and you can also plot the points and determine that as well. Your book gives you a definition for domain and range, but notice for A, this is 1, oops, I don't know why it's doing that, 1, 2, and 3. And notice all the y's are different, but each x has its a range, right? And so really, what does this look like? If you have a graph, it looks like y, x, so 1, 2, 3. All right, and so this is a function. However, let's take a look at g, and this becomes this is one way. So 2, 2, 2, and this is 1, 2, and 3. And so this looks like 1, 2, yx. And here's our line. Now this is not a function, okay? Every domain has a range, but notice there is, the domain is the same. There's one value for the domain. No, because the input values has two different values, okay? So notice you're putting in 2 and you're getting 1. You're putting in 2 and you're getting 2. It has more than, the input value has more than one value. So in order for it to be a function, your input value, okay, can only produce, you can't have, so like for example, if you put in 1 and you get 2, and then you put in 1 and you get a different number. So notice you put in 1 and it gets 2, but let's say you had 1 and you get 4. Oops, let's go back. This would not be a function, but that's not the case, okay? So the input value can only have one output value, okay? All right, so identifying a function graphically, there's something called a vertical line test, again, in your book, a vertical line test. So if I give you a function, all you have to do is you draw a straight vertical line through it. And if it only crosses the graph once, you have a function. So that's kind of nice. So let's determine whether these are functions. The slides are going to give you a graph, okay? Oh, it's not going to give you a graph. So let's just talk about this real quick. This is like saying y is equal to 1/4 x, okay? This is like saying y is equal to 1/4 x, which is just a line. And so all linear, typically linear, squared, cubic functions are functions, okay? Now this represents a circle, and what does that look like? It's like this. Well, notice it crosses the graph twice, so it is not a function.